Hi, this is Julie Harland, and I'm your Math Gal. Please visit my website at yourmathgal.com, where you could search for any of my videos organized by topic. We're going to do this investment simple interest problem and use one variable to solve it. A total of $7,000 was invested in two simple interest accounts, such that the annual interest earned in each account was the same. The interest rates of the accounts were 15% and 20%. How much was invested in each account? All right, so we have a total of $7,000 to invest. We certainly aren't just putting $3,500 and $3,500 in each account, because then, of course, we would get different amounts of interest at the end of the year. All right, before going on and setting up this problem, just remember the simple interest formula. All right, the formula we're going to use is interest equals rate times principal, because we're talking about 1 year. So up at the top here we have the letters used for the basic formula. Interest equals principal times rate times time. But for 1 year, putting in 1 for t, we get principal times rate, or rate times principal. And so we've got a quick little example down here. If you invested $5,000 at 1 year, at 6% for 1 year, you would earn $300 in interest. So we're going to use this formula, I equals the rate times the principal. So here's our problem again. And so we've got two different kinds of accounts, and I like to make up a chart to keep track of the accounts, the percentage, and the amount I'm putting in each account, and how much interest I'd earn. So we have two kinds of accounts, right? We have one account that happens to earn 15% per year in interest, and the other one 20% per year. So I like to write down what my rate is in terms of a decimal. So 15% is a decimal. You move the decimal 2 to the left, right? 15% is written as 0.15, and 20% is written as 0.2 or 0.20. It's up to you whether you want to write it with the same number of decimal places. All right, now what about the principal? Okay, so this is the tricky part. We have a total of $7,000. So we don't know how much is in either account. All right, so we're going to use one variable. So let's just say we put X dollars in one account. What we do know down here, if you want to write it down, is that the total amount of money we've got is going to add up to $7,000, right? So X plus what will give me $7,000? Okay, well, if you have $7,000 and you already put X dollars in one account, you got to subtract that to see what's left. So this will give me 7,000 minus X. And notice that if you added X plus 7,000 minus X, it does add up to $7,000. So we've defined our variables. X stands for how much money we're putting in the 15% account. 7,000 minus X is how much we're putting in the 20% account. So the interest is the rate times the principal, or the principal times the rate. I write it like this because it's usually easier to write the decimal in front of the amount. So in the 15% account, if I do the rate times the principal, I have 0.15 times X. Now in the 20% account, if I do its rate times principal, I have 20% times, now remember, this is a whole quantity, 7,000 minus X. So we have to put 0.20 times 7,000 minus X. All right, so that's how much interest is earned in each account. Now what do we do with that? Well, we've got to look back and see what it tells us about the interest. Like, does it tell us how much the total amount of money that is, etc. So we look through the problem again. A total was invested in two accounts such that the annual interest earned in each account was the same. Well, what does that mean, the interest is the same? That means these two are equal to each other. The interest earned in the 15% account is the same amount of money as the interest earned in the 20% account. So that's the equation. You have to figure out how to write an equation based on what the problem says, and the key here is the word that it's the same amount of interest. So let's write the interest earned in the 15% account, we look up here, that's 0.15x, is the same as the interest earned in the 20% account, which is 0.20 times 7,000 minus x. Now, if you're comfortable working with decimals, you can go ahead and solve that right now, keeping the decimals. In fact, good idea. Why don't you go ahead and put the video on pause and try this on your own? I like to remove the decimals, and the way to do that is multiplying both sides of the equation by some number that eliminates the decimals, and that would be 100. So I'm going to multiply both sides of the equation, and the way I show it is with these brackets. But remember, I'm not just multiplying the left by 100, I'm multiplying both sides of the equation, both sides of the equation by 100. So if I do 100 times 0.15x, it's going to move the decimal 2 to the right, so I just have 15x. If I multiply 100 times this on the other side of the equation, it moves the decimal 2 to the right, so it's just going to be 20. Now you don't also multiply what's inside the parentheses, okay? All right, you only multiply it once. And this is times something else, so you don't want to multiply it by 100 times 100 again. So I have 20 times just 7,000 minus x. All right, so I like to do this just to make the numbers all whole numbers. So I have 15x equals, now I'm going to do the distributive property over here. So I'm going to multiply 20 times 7,000. So what's the easy way? I'm just going to do 2 times 7, which is 14, and then I'm going to put all the extra zeros there. There's 4 zeros. Okay, minus 20 times x will be just 20x. All right. So next step is I have to get the variables on one side and constants on the other. And so since I only have one constant on the right, I'm going to put the variables on the left-hand side. So I'm going to add 20x to both sides. Right? So what does that give me? I've got 15x plus 20x. Remember that's separate from this 15x up here, right? Just 15x plus 20x is 35x equals 140,000. So the only thing left to do is divide by 35. And you can get a calculator out and do that. I don't need a calculator because I'm going to think how many times does 35 go into 140, and that will be 4 times, okay? And then these 3 extra zeros. So you should get 4,000. Or you could do long division. Or you could just start canceling, divide top and bottom by 5 first. Or you could start canceling by dividing top and bottom by 7 first. Okay, lots of ways to get x equals 4,000. What did x stand for? Let's look back up. In my picture here, x stood for the amount of money I put in the 15% account. Okay, right, the principal here. So here's my x. So now I know x was $4,000. I'm going to write that here. So remember, we got, just keep in mind, that x was $4,000, right, when we solved it? And we had $7,000 total to invest, so we must have $3,000 in the other account, which of course is the same thing as $7,000 minus $4,000. So it looks like we're putting $4,000 at 15% and $3,000 at 20%. Okay, so we definitely want to check it. We want to go back to the original problem and see if that makes sense. So we've got 4,000 at 15%, 3,000 at 20%. Okay, so here's the original problem, and we came up that it would be 4,000 at 15% and 3,000 at 20%. Definitely want to check your answer, so let's just check. All right, if you put 4,000 at 15%, in a year you would have the rate times the principal, so you'd have 0.15 times 4,000. I think that's $600 in that account. Okay, and then let's check the other account. So what would 20% of $3,000 be? and that also happens to be $600. Okay, and how you multiply this, you get a calculator out. You could change this to fractions, which makes it really easy, by the way. If you wrote this as 1500ths, it's real simple to do the arithmetic. And if you wrote 20% as 20 hundredths, it'd be really easy to do the arithmetic. All right, so lots of ways to get that they check. Now, what did it say? I wanted to make sure the annual interest earned in each account was the same, and yeah, all right, it did come out the same. So this is the correct answer, $4,000 at 15% and $3,000 at 20%. So this is a way to do this problem using one variable. Please visit my website at yourmathgal.com where you can view all of my videos, which are organized by topic.